Okay, example 8. A vacuum parallel plate capacitor has plates of area 150 cubic centimeter and a separation of 2 millimeter. The capacitor is then charged to a potential difference of 2000 volt. Then the battery is disconnected and a dielectric sheet of the same area is placed between the plates. In the presence of the dielectric, the potential difference across the plates is reduced to 500 volts. So determine the initial capacitance of the capacitor, charge on each plate, capacitance after the dielectric is in place, relative permittivity, permittivity of dielectric material, initial electric field, and lastly electric field after the dielectric is inserted. Okay, so first let us extract the information we have. So firstly we have the area. So this is 150 negative 4 cubic meter, and then we have the separation, which is 2 times 10 negative 3 meter and then the potential difference 2000 volt, and then the volt after dielectric is inserted 500 volt. Okay, so the initial capacitance of the capacitor is given by E naught A over D. So this will be equal to 6.63 times 10 negative 11 farad. Okay, so this equation is given in our notes, so just make sure you know which equation to use based on the situation lah. Question B pula, the charge on each plate, you can just directly use this formula before the dielectric is inserted. So use the values before the dielectric is inserted. So this is 1.33 times 10 negative 7 coulomb. Okay, and then question C pula, capacitance after the dielectric is in place. Remember remember the after the in the presence of a dielectric, the charge on each plate will be constant. Okay, the charge is constant even after a dielectric is inserted. Okay, so the new capacitance is given by 2.66 times 10 negative 10 V. Okay, and then question D pula, relative permittivity is this one, dielectric constant. Okay, dielectric constant, so this is C over C naught, so you'll then get 4.01 as the relative permittivity. Okay, and then question E, permittivity of dielectric material, just use this relationship, so we'll get 3.55 times 10 negative 11 coulomb square per Newton per meter square. Okay, so make sure you are able to memorize the units for each of this term. And then question F pula, this is gonna be equal to, we are gonna apply the relationship between E and V. So this is E naught equal to V naught over D. So just substitute all the information, so we'll get 1 times 10 to the power of 6 volt per meter. Okay, and then lastly the electric field after the dielectric is inserted is equal to EV over D. Okay, just use the potential difference at 500 volt lah. Okay, so the answer is 2.49 times 10 to the power of 5 volt per meter. Volt per meter. Okay, so that is the solution for example number 8.